Thank you, Michelle, for that kind introduction. G'day, so my name's Chris, and today I want to talk about how functional programming applies to the World Wide Web and delivers there on FP's promises of productivity and safety. As Michelle said, I run a business called Accelerando, which is all about rapid prototyping. We use technology to reduce stress by getting computers to worry about the things that you don't, so that you don't have to. And this mindset, for me, extends to our taste in development tools. Have I got notifications happening up there? No, good. So today I'm going to give you a capsule introduction to the philosophy of the Elm language and a brief look at its syntax. I'm not going to try and teach you the language. There's a wonderful talk from a couple of years ago that I'll link to at the end from Jessica Kerr, which does an excellent job of that. But rather, I'm going to look at how to get started in learning Elm under your own steam and why you might want to try. And we'll do this in the context of writing a real-world but simple application, leveraging some of the features in the latest release of the Elm runtime. And along the way, we're going to look at how Elm fits into the wider JavaScript ecosystem and what you might need to know if you've been developing on previous versions of Elm. For those of you who are new to Elm, it arose from a university thesis on functional reactive programming by a student named Evan Kazaplicki. Now, I know what you're thinking. It's one of those toy academic functional languages that is as pretty as a kitten in a pink bow, but about as useful as a meat raincoat in a tornado full of hyenas. But it's not. Elm is a remarkably useful and practical functional language which compiles to JavaScript, runs in the web browser, and does one thing better than most of its competitors, and that thing is safety. The promise of Elm is no runtime errors ever. You never get that damn null object error, and that's not just because Elm doesn't have any objects. The way Elm does this is by being pretty darn strict about what you can and can't do. It's a small language with a simple but not too simple type system. It's about as much of Haskell as you can fit on the back of a postcard. We have immutable data, thus no variable aliasing bugs. We have strong typing, which means no data type or missing method errors. We have algebraic data types which let you express ambiguity on the page rather than in your head, so no null pointer errors. Higher order functions and extensive use of partial application and composition provide a surprisingly rich palette of operations from a rather quite small standard library. And side effects are very strongly constrained, and the upshot of that is that the language actively helps you cover all the possible edge cases. So what is working in Elm like? The Elm core libraries enforce a structure to your program that funnels all of the complexity into one place and uses the type system to insist that you handle all the uncertainties meticulously. The compiler has got your back. The safety features of the language mean that refactoring is your go-to tool. Rather than designing an architecture complex enough for any possible eventuality, which is the typical approach in a pure JavaScript framework, Elm encourages you to begin with a blank page and iterate fast, with the knowledge that the compiler, if it okays your program, it's going to run. It might even run where you want it to go. In an Elm program, you have exactly one variable, which we call the model. Messages from the outside world come to your update function, which updates your model, and that update operation emits a new model and potentially some actions. You don't have to worry about updating the screen because the language handles it. Each time the model changes, your view routine is called to render the state of your model as a web page, and then the language efficiently figures out how to update the screen via the document object model to render that change. And there's a good helping of virtual document models, tree diffing, tree shaking, and all the cool buzzwords which make what sounds like a pretty insane idea to actually be efficient. So I'm going to talk about a made-up example which isn't actually made up because it's a cut-down version of an app we wrote at Accelerando earlier this year. We did actually we didn't write it in Elm, we wrote it in React because hand-wavy reasons. But the whole time we were doing that, I was wondering whether it would have been easier or harder to do it in Elm. So when the opportunity came to write this talk, I rewrote that app in Elm to see how hard it was. And this is an app for measuring the for managing the video distribution hardware in a sports bar. If you've ever been unlucky enough to visit a pub in this century, you might have noticed that there are TVs everywhere. Our client created a product that escalates this audiovisual nightmare by tunneling HDMI over multicast IP. They take two kinds of black boxes. One takes HDMI in and multicasts UDP out. The other receives those multicast streams and emits HDMI. That means instead of running HDMI cables everywhere, you can just run plain old Cat6, install these boxes, and spend the money you saved on more goddamn TV screens. And both the transmitters and the receivers can be set to a channel, which is pretty much all they do. You put these things in, you give them an IP address, you set them to a channel, and then you forget they exist. So our model in Elm that expresses this is just a list of the devices that we know about and which one we're currently looking at in our app. Each device has nothing more than a name, an address, a device kind, and a channel number. So what are the things that can change our model? Well, at startup, we scan the network to discover the devices that are present, and hopefully we find some. The whole point of this application is to change channels, so we have a message to do that. And during the installation process, we want to give devices a meaningful name and address. The update function is the core of your application. Every time the update emits a changed model, the runtime calls the view function, which renders that model. And there's a whole raft of stuff, as I said, that happens behind the curtain to avoid wasting time and rendering unchanged views. But in practice, you as the developer barely care. You just write your update and your functions as if CPU cycles are unlimited and let the architecture handle the gritty details. And that mess up there, which is perhaps not code I would recommend you write, is what happens when you take a literal-minded approach to representing your model in HTML. The functions for rendering elements that are available to you mirror the document object model, but later on we'll look at some more idiomatic approaches to rendering that are a little more high level. Now, right about now, those of you who do any amount of web programming will be muttering that this all sounds an awful lot about like React and state machine engines like Redux, and you'd be right, but arguably that's because it's the other way around. A number of popular JavaScript frameworks, including Redux, are very upfront about their existence being a conscious attempt to replicate the Elm architecture in pure JavaScript. And in my experience, dealing with programming in tools like React and Redux can become an exercise in whack-a-mole because you do have the same concepts. Redux's store is the same as Elm's model. Redux's actions are Elm's commands, and Redux's reducers are Elm's update. But when you're working in JavaScript, it's all up to you. If you add an action and forget to update a reducer, nothing warns you. If you typo the name of an action, then, well, you're probably spending the afternoon chasing that rabbit down the rabbit hole. You get what I call the Star Wars effect. Beautiful architecture and no safety rails anywhere. But hey, there's bolt-on type systems for JavaScript, like TypeScript and Flow, which can give you a partial safety net. And definitely, if you're coding in JavaScript, adopt one of those. But even if you're going to stick with working in JavaScript, it's my opinion that giving Elm a try will improve the way you think about building web applications and coding in JavaScript. So I do encourage you to give it a try. So, how do you go about dipping your toes into Elm? Well, if you have an existing web app, you can Elmify it one component at a time. Within your layout, you render an empty component with a particular ID, and then you tell your compiled Elm application to render into that div. In fact, it's recently become even easier because somebody has written a React component which encapsulates that whole notion and lets you do it in essentially one line of code. But before we move on with going deeper into our single page app, I want to throw you a mid-season cliffhanger and change tack to talk about what's changed in the latest release of Elm. which happens about once a year. Although given that we're up to a version 0.19 and it's not 19 years old, that's probably not very accurate, but it's near enough. But yes, I said 0.19. Now Elm really gets behind semantic versioning, so that 0 means something. It means under construction. The scaffolding you're standing on might get removed while you're still standing on it. But again, this is a case where the language and the architecture helps you out. So let's briefly go through the changes in this release. The command line had a major refactoring, merging all the entry points like elm-make and elm-package into a single command. So unfortunately, all your build scripts broke. But on the good side, previously there were 5 or 10 different modules that you had to import to properly do responsive web pages. And there was no one anointed way to structure a single page web app. Now, some of those modules were core modules and some of them were third-party modules. And now what's happened is that the most useful patterns have been brought into the core libraries, and all the essentials you need to build a responsive web app are unified under a single module called Browser. And there's also been a simplification in string to number conversion, which reduces code complexity without sacrificing too much safety. And finally, there's been some aggressive optimization that has led to faster compilation and smaller web objects. When I was working on a fairly large app in Elm last year, compilation time from a file save to being able to view it on screen was perhaps 5 to 10 seconds, and it got pretty interminable. With the changes in Elm 19, it's so fast you barely notice. And size-wise, we find that a compiled Elm app can potentially be a quarter of the size of an equivalent React app. And in fact, the outputs are so small that we have successfully deployed Elm applications into IoT devices the size of a postage stamp. There's a water meter out there that runs its configuration UI in Elm. So you put all this effort into writing an Elm app, and then the next release of the language totally breaks it. Well, that's kind of true, unfortunately, from a certain point of view. But again, this is where the language comes to our rescue. The vigorous suppression of side effects means that automated refactoring becomes quite a tractable problem. So there's an automated migration tool that's part of the latest release, which can rewrite your program to resolve most of the breaking changes in that release. And we'll come back to that a bit later. But now let's come back to our single page app. But I suppose really I should define my terms. What do I mean by a single page app? Traditionally, every time you clicked on anything in a web page, you got a whole new page load. Then Ajax came along, popularized by Gmail, and you could update parts of a page without having to reload the whole thing. But Ajax broke the back button.
Ajax is introduced by Microsoft in Outlook, not by Google and Gmail.
Thank you for that entertaining correction. If you modify so much state that the user thinks of the page as an entirely new page, then they have a right to expect that the back and forward buttons will do what they expect. And we also want to retain the ability to do deep linking to represent some internal state of the application as a URL that we can request from the outside as an entry point. So to enable those goals, JavaScript gained the ability to manipulate the single page URL and the browser history to make a single page look like navigating amongst distinct pages. This is what we call a single page app. It may look like a bunch of distinct pages with distinct URLs, but it's just one page load and then a bunch of faster API calls. And that has two key benefits. Firstly, faster. Secondly, we have the possibility to create web apps that can actually work offline. So how do we create a single page app in Elm? Well, just like anything else, you Google, how do I create a single page app in Elm? And just like anything else, you get a bunch of answers that are wrong and out of date. So in the JavaScript world, getting started can be so complicated that there are a number of boilerplate projects that give you all the framework of a complete project into which you can drop your code. And there's plenty of those for Elm as well. But in my experience, that's not the best approach, because building a complex structure too soon slows you down and makes it harder to learn the language. So I prefer to start out with a single file where I can see my whole app literally on one page. And so I found one tool that I think splits the difference wonderfully. If you work in React, you might have come across a script called Create React App, because it's down near impossible to get started in a React project without something to marshal up all those dependencies for you. Well, starting an Elm project from an empty file is quite easy, but some folks out there have taken inspiration from that Create React App and written a very useful tool called, funnily enough, Create Elm App. And what this does is takes care of setting up all the peripheral resources you'll need for development and application packaging and things like hot reloading, but it still leaves you with a single small file that contains one page of code to be the skeleton of an app. And the other benefit that it has is that any compiler errors you get, rather than going to a terminal window somewhere, come up in the browser window. So that's one less screen you have. You can your workflow becomes editor here, browser there, and every time you save your file, your page reloads or crashes. But if it does break, the compiler messages are really helpful. And this is something that Manuel spoke about yesterday in his workshop, that Elm goes a long way to make its error messages helpful and aimed to encourage you to learn the language and find your way about. So if you forget to import a module or a symbol, the compiler will suggest perhaps you meant this module. If you misspell a function name, it'll do the same. If your argument type or count is not right for a function, it will explain the situation. And because we're making heavy use of partial application on functions, you'll really come to appreciate the error message that you see a fair bit, which says, whoops, looks like this function was looking for one more argument of type X. So let's look at how we manage browser history in a single page app in Elm. When we create an Elm program, we tell it what kind of web element it's going to be, whether we're embedding into a single div in an existing page, whether we're rendering an entire page as a standalone page, or whether we're building a whole single page app that represents multiple pages. There are different entry points to the Elm runtime for each of those cases. And the extra wrinkle that application entry point gives us is two messages that the runtime receives whenever the user initiates a URL change and whenever the browser completes doing a URL change. And that gives us the ability, firstly, to rewrite the history and make the back button work, and secondly, to extract state from the URL in order to handle deep linking and to render different views for different URLs. And it's been a common pattern previously in Elm applications to abstract URLs as what we call routes, and this is now an officially anointed pattern as part of the core libraries. And in this case, we define the possible kinds of page that we want to display, and then we map the input URL onto one of those route types, extracting any necessary parameters from the URL, such as the query string or the URL fragments or path parameters. And then we throw the URL away and we work with those strongly typed route objects. And now when we call our view function, we can make a top-level decision on what kind of page we want to show the user, and then dive off into different code for each page. And you can go as far as separating each page into its own model with its own update and view function. But once again, this is a pattern that you would reflexively use out of the box with something like React. But in Elm, it's something that you can save until later, and you can fly by the seat of your pants until you think the necessary refactoring is worthwhile. And in practice, it almost never is. Although we are getting there with one application that is developing into a bit of a crawling horror. Another welcome feature in the latest Elm is file uploads. Previously they weren't too difficult, but they were very obscure, and you had to work between JavaScript code and Elm code and pass bits of base64 encoded upload around to make a file upload happen. Now in Elm, processing a file upload is literally a one-line operation. And that also works with drag and drop and progress notifications and image previews. So that's a feature that I'm really keyed up about, except that now we have to rewrite a bunch of code that we bled all over a couple of years ago to get the behavior we wanted. And there's also been a major simplification of HTTP requests. Last year, doing an API call looked like that. We had to create a HTTP request, set a bunch of parameters on it, define a handler to process its response, and then emit a command to send that request, and then later on receive the processed response. In the latest Elm, it all happens in one step. You make the return message becomes part of the response handler, you create and send a HTTP request in a single function call. And that makes those bits of code small enough that you can inline them into your update function and end up with a much more readable program flow. Now, there is one area where Elm gets frustrating, and that's component frameworks. There's not a huge amount of choice. And in fact, there's a faction of the Elm community which thinks that the very concept of a web component framework is not even the right way to do functional web development. Your two main choices, if you do want off-the-shelf web components, are currently Bootstrap and Material Design. And we've been working with Material Design, and there was a lovely set of modules that implemented Google's Material Design Lite framework, and we wrote a lot of apps with those. And then Google pulled the plug on the whole project, and the authors of that Elm module decided that, well, if Google wasn't going to support it, they weren't either. And then Elm 19 came out and broke that module, and then I had no web framework. But now there is an Elm library called Elm MDC, which implements Google's new framework, but unfortunately there's some degree of uncertainty in the material design community as to whether Google is going to torpedo that one in favor of yet another framework. So development on that project is not going as fast as it could. It's in beta, it works quite well, I've not had any problems with it, but it hasn't been uploaded to the Elm package library, which means if you want to use it, you have to install it manually. Fortunately, pulling in a third-party module or maintaining your own set of modules is pretty simple in Elm. You just need to edit your config file to add your source directory to the module source search path. And that mess up there is the steps to bring in Elm DC to a project that had been created by Create Elm app. So first, we install some dependencies, which the package manager would have done for us if the package was in the repo. Then we pull down the code from GitHub, which the package manager would have done for us if it was in the repo. Then we paste in the standard Google style sheets and JavaScript and the style sheet from that library, which we would have had to do anyway if it had been in the library. And then we're off. And if you've used Material UI components in React, you'll be very much at home with these. They work pretty much the same way. So what does our app look like after we materialize it? Well, the material design component set has its own model under the hood and generates and handles its own messages. But fortunately, that's almost completely opaque to us. All we have to do is add one component to our model, one component to our message type, one in our event subscription, one line in our update function, and we're plugged in. And when we adopt those material design components, our view rendering becomes much more abstract because we're thinking at the component level. And just like in React, there are two broad types of components. There are the complex ones that accept or emit messages, and the simple ones which don't. And the complex ones have their own view function, which is a little bit weird, but you get used to. And the simple ones work just the same as any of the other HTML components. But again, don't do what I did up there. I defactored that code in order to be able to give you enough context on one slide to get a feel for the syntax. What I would really do is write functions that mirror the logical arrangement of my pages. This allows, for a language that isn't actually object-oriented, a surprising degree of reuse. We have an inventory application for emergency services where the rendering of a vehicle manifest for a shift handover checklist and the rendering of the complete inventory system for the administration system is actually the same function getting reused in different contexts. So if you structure your code right, you still get quite flexible reuse. So let's say you've gone the route of embedding a component, an Elm component in an otherwise JavaScript project, or you've done the reverse. You've taken an Elm application, but you need to use that one JavaScript component that hasn't been ported to Elm. Then, and you'll probably end up doing that most likely if you're using a mapping engine like, say, Leaflet. How do the two halves of your split brain communicate? Elm's answer to that is called ports. And a port is a typed unidirectional channel between the world of Elm and the world of JavaScript. And you can be lazy and just pass a chunk of JSON across as a string, but you really are better off applying some more detailed typing to those ports so that you sacrifice as little safety as possible. And one place where I find myself passing information down the rabbit hole from JavaScript to Elm is using authentication libraries. When we use Amazon Cognito for user management, it looks like this. In our JavaScript code, we set up our Cognito client and we register a handler that will receive the result of a login. And when that happens, we grab the token that the Elm code is going to need to call our API, and we pass that down to Elm through a port where Elm can stash it away in the model. And as an example of going the other way, let's go back to our video distribution application. In a facility like this hotel complex here, where there are approximately 52 quadrillion corridors and rooms, we want to be able to display a scrolling map of where every screen is so that we can find the darn things. Our Elm application fetches the location information from our back end, and we embed a leaflet map into our JavaScript DOM, but we're going to need to pass some markers up from Elm, up the rabbit hole, to populate our map. So when we receive our API result via our found devices message up there, we do our normal model update, and then we emit a new action which writes to a port. And then on the JavaScript side, we register a callback function that runs whenever data arrives on the port. If you've programmed in Go, it's very much like using channels in Go. And one last thing, while nobody was looking, web browsers added the ability to define custom HTML elements. This is kind of bleeding edge, and it's only well implemented in Chrome and Firefox right now, and I'm sure people will do horrible, horrible things with it, but you can do those horrible things in Elm as well. And this is another way to embed complex JavaScript components into your app by treating them as essentially new HTML elements. I haven't had much of a chance to play with this myself, so I won't say too much more about it, but there is a video from last year's Elm Europe linked there which goes into some more depth. Okay, the last thing I want to talk about is the nitty-gritty of migrating to Elm 19 if you're an existing Elm programmer. So I took the code that I presented here at Lambda Jam last year and followed the migration steps, which involve running a tool called Elm Upgrade. An Elm Upgrade is largely a wrapper around Elm format, which applies some canonical formatting rules to your code so that your syntax-directed editor can handle the whitespace sensitive language. But it also knows about the various versions, which means you can tell it to translate between the syntax in one version to the syntax in the other. And when you run this upgrade, the first thing it does is migrates your configuration files, then works through your dependencies. It's nice enough to ask permission before wrecking too many things. And after that, it goes through your code and processes any function renames, removals, and in the cases where it's too hard to automatically convert, then it prints out some helpful instructions to tell you what to do. And boom, you're up to date. So to recap briefly what we've seen, we've talked about how Elm is awesome, how Elm and JavaScript can be complementary. We've toured some of the new features in the language, gone through the process of building a single page app with the Create Elm tool. Web components are still a bit of a sticky wicket, and we've looked at how to bring the Elm material components in. And finally, we've looked at how to use ports for interoperation between Elm and JavaScript, and we've seen an example of migrating to version 19. So thank you very much for your attention today. I hope you found that useful. I am in receipt of approximately 40 seconds for questions, but I will be here for the rest of the event, so look forward to talking to you. Thank you very much.
Fantastic. So